Hello and welcome back to episode 3. So, KTools is going to take a little turn here and get a little more abstract, which is kind of always the plan anyway. But, um, cellular automata. Now, I'm not going to go in and, write out the algorithms that have already been put out there. It's well documented how to do all this, but essentially what it is, you have this voxel space, and then you define like rule sets based on, think of it like each voxel is a bit, so 0 or 1. And based on like if the neighbors are 0 or 1 and you're 0 and 1 in your location, then the next neighbor would be 1 or 0. Or so you create these rules, and then what you do is you combine different rule sets to get different structures to generate. Um, anyway, I'm not gonna like go in and implement some research paper or anything like that. I'm just gonna kind of do what I do best and just wing it. So anyway, here in KTools, I have this module that I put in utils called graphics. It just allows you to create points batch, draw points batch, create lines batch, draw lines batch, triangles, triangle, smooth triangle. Anyway, and it has some font stuff down here as well. And all this is on the GitHub, but and this is actually from the course. So if you want to watch the course, see how this is all written out, what it means, yeah, link in the description. But so ops, we're just going to create a new operations folder. Let's actually, categorize this stuff. So I'm going to put a folder and call it procedural. My spelling is, I'm not the best at spelling. I think it's maybe a form of dyslexia or something, but here's ops, and then I'm going to do mesh. I'm just going to put this stuff into mesh, and I'll just move it, and let's see if it imported. So we'll just go ahead and change that. I'm just basically making our category so I don't blend all this stuff together, because it's going to get a little crazy if we start doing that. And we'll just have to put in a init file, and that turns that into a module. That's good. And then over, well, actually I need to make sure I don't break this stuff, so I got to change my imports from .utils, and mirror is going to be .utils. All right, because it's got to go 1, 2. You got to go. This is where you're at, and then 2 folders up. So that looks good. I'm going to copy this one, this mirror operator, and let's see. So procedural, and then I'll just go in here and say, well, I'll make the init file real quick. All right, and then let's do. I'll just create one called voxel gen v1.py, and I'll paste that in here. All right, I'm gonna back this stuff out, and there's a few things I'd like to do to set this up, and we'll just return true. All right, and this thing's gonna basically nuke the scene. I don't really care. This is just for experimentation, just a little R&D more or less. So what that means is I'm going to delete everything in the scene as soon as this thing spawns in. I guess. Do I want to do that? Maybe I won't do that. Anyway, well, I do want to do that sort of, because maybe not actually. Maybe I'll make an object property. Yeah, I'll just do an object property. So let's say voxel, because I want it to play across the animation system. So I don't want it to like, just spawn a mesh. I want it to actually, animate. Possibly. I'm thinking possibly. We'll see where we get. So voxel gen v1, and yeah. All right. I know this is like most repetitive. Voxel gen v1. Okay. I'm just gonna make sure I register that. So from dot procedural dot no dot voxel gen. What I'm thinking here. Import this. All right, and I'll say this is going to be procedural. And I'll just make sure this says mesh. That way I can quickly, categorize things. Mesh and procedural. All right. So I think that looks good there. And what I'm going to do in the panel is this panel, View 3D panel, I'm going to change that to View 3D panel mesh. And this is going to be KTools -mesh. Okay, that View 3D. I just need to make sure I update that. All right, View 3D panel. I'm going to actually duplicate this, and that'll be for mesh. And this one's going to be, wait, that label. I want the label to, oh, I meant to put this as the label. And I want to do this right there. Okay. So KTools, and this is going to be procedural. It's going to be half the video of me trying to spell procedural. But anyway, who cares? Okay, I think that looks like everything. And then I'll just say, you know what, I'll do this right here. And then I'm going to put this label as voxel gen. I'll just put voxel. And for this, we'll just put in the BLID name. Text is voxel gen v1. We don't want this operator. And I don't need the box layout. Yeah, that's fine. Well, we can always just, update things as needed. Okay. So let's just load up this thing here. So we need to import that new interface. Did I change the name? Panel procedural. I'll make sure I import that. And we'll just do the comma version there, or the version where you import with parentheses, just to keep it kind of vertical, more readable. All right, looks good enough for now. I just want to get this thing started more than anything. So we'll do Blender start and just see if our operator shows up. See if I got everything set up properly. All right, and KTools. There it is, KTools procedural, voxel gen. All right, looks like this operator is set up. So what I'm going to do here is when you click on it, if it's already registered, then it'll remove it. And then if it's not registered, it will unremove it. Or, well, you know what I'm saying, it'll start and stop it. We could actually create two buttons for that, but I won't do that because we don't need to. Let's see. So let's create a class, and we'll just call it data, just because I want some global class. So we'll say we'll have to have like some global class in the module level. So when the add-on is loaded, it will load this class into the module, or well, this class and everything in it becomes part of the add-on's memory. So while Blender is running with the add-on enabled, everything in this class will also be in memory. So that's kind of the crappy part about the script editor is like once you run a script, it takes that script and goes and runs it in the background, and then you kind of lose your reference to the memory that it was created. So if you have a function that's a callback and you register into Blender, well, your script, when you run it, it runs it and then it's gone from you. So the only way to handle, unregistering things is to put checks in the callback functions to remove themselves, so it gets like complicated. Um, anyway, let's just look at getting the 3D graphics drawing. So I'm gonna just bring over a little bit of code here, and this is gonna be this right here will actually get that code to start. And let's put gen for generator. All right, so we'll say handle post view equals none, and this is where we're just going to put it. We're going to just say gen dot handle post view equals, and then we need to have this a draw function on here. So we'll just do at class method, we'll do def, and then we'll say draw post view. Whoops, draw post view, and we'll let it take in the class, and then put pass for now. So we'll say gen dot, well, it's all caps, gen dot draw post view. All right, I think that will be fine. Okay, what we could actually do on gen is say, well, we'll need to actually create the, we'll need to create, let's see, in props, add-on, let's do props, and then, I don't want to use object properties just yet. I could put like, a property on objects, but that doesn't tell us if the shaders or anything else is registered. So we'll just say registered equals false. So we'll say if gen dot registered, then we'll remove. So this will be stop, and then we'll say else, and this will be start. All right, so gen handle post view bpy. Let's just import this as a type here, and that way I don't have to have so much code going on here. So let's see here. We got gen handle post view, and then if gen registered, what we'll do is say gen dot registered equals false, and this one we need to set to true. Okay, so gen dot registered, and then let's also make sure we remove. So we'll say if gen dot handle post view, then we'll need to remove that. We'll need to remove that shader. So I'm just copying from over here. I really need to get rid of that hotkey. Shift enter will run like the Python file just in the terminal, or start Python. Anyway, if gen handle post view, then we'll remove it, and then we'll also set it to none. Okay, I think that's everything for the handler. And so let's see here. Yeah, sorry, I'm not the best with commentary while I'm, trying to do something like this. More or less just interested to see what I need to do here. And there's also, some interesting things with the API. So, you have the bpy.app.handlers, and you can do frame change pre right here. And this can be done, like you can have a handler or a function callback that before every frame change, it'll call your function. And so if we want to like update, basically it's like simulation nodes and geometry nodes. So we can have like a function here, and we could say frame change pre, like that. It also requires, I think I can do this, where you pass in scene and the depth graph. I don't know if it'll let me do a class method. I think it will. So we'll just try that real quick. We'll put this here, and we'll say, we'll just assign it dot append, and we'll put gen dot frame change pre, and then we need to remove it in this one. Well, I can leave that there, but I'll say remove, and then it's a good idea to check if frame change pre in. There you go. And let's get that outside the handle post view thing. Okay. So I think that will do it right there. And you know, there's another idea too, is that we just remove everything no matter what, and then just start it. So we'll just say, you know, remove all, and then no, I'll just leave it. I'll leave it. I don't want to get too complicated with myself. Okay, we'll say refresh, redraw. That's fine. Just leave it as redraw. Tag redraw basically just gets the Blender viewport to redraw, and it's on the area, so it's only going to redraw the area. So like since we added shaders and stuff and removed them, it's a good idea to redraw. Let's get this up one level. Kind of pointless, really. I don't think I'll be using layout or any of the properties, but I don't know yet. Actually, yeah, I will. I might be doing that. So frame change pre. Let's just go ahead and print everything, see if we get it. So we'll say, I'll just print the function name. So print function name there. Get me out of here. Okay, and print the function name there. Now let's just go in here to Blender and see, bring up that terminal. Draw post view, that's working. If I hit spacebar, you can see we're getting the frame change pre as well. Now if I push it again, everything should be unregistered, and I think that it is. So we have our callbacks registered, which is good. We could even have a 2D callback as well, so I'll just add that just in case we want to draw some text. So draw post pixel, that's the 2D version. Alright, so let's get this in here. Draw post view. This one's going to be draw post pixel. And we'll just put post pixel like that. And we need to make sure we have this property on here equals none. Handle post pixel. So let's just say we're going to just do this and just replace it with post pixel. And we'll make sure that this is drawing as well. Post pixel. All right. Doesn't look like it did add it. Oh, because I need to set the right function. Okay, so let's see. Yeah, we're definitely getting everything now. And when you're doing stuff with callbacks and you're using the Visual Studio Code to auto reload when you hit Control S, so like when I save, it reloads. Just make sure you don't have anything registered in here into the scene, because you'll lose a reference to it. You can also use, you know, load pre, I believe. Yeah, is that the one? On loading a new blend file, you know, just make sure that you use that to unregister. You know, and we can actually just move this. So we'll say, this will save it. I'll show you what I'm saying. We'll say @class method, and then we'll say def remove handles. We'll say remove, just remove. That's all we need. And we'll just put this up here. And since we're using the CLS, it's a class method, I can just replace the name of the class with CLS because that is the class. Now, do know I am doing all this as it's not class instance. This is going to be, this is a class level attributes. Big difference. All right, so we'll say if gen.registered, and then we'll do gen.remove like that, and now we'll call this one, and then we can say gen.start, well, class method, and we'll say setup. Yeah, that looks good, and we'll just put that in there. Alright, so we've done a lot of boilerplate coding, more or less, and we're still not quite even done with that, but we're getting there, because next we can actually draw some stuff and start trying to define our grid. So I think that is going to do it. Okay, let's just might have to restart Blender. We might have some callbacks stuck in there, but the point is like whenever the add-on reloads, what I want to happen is that we call this function. So in the init for ops on unregister, what I'd like to do is I'm going to say procedural voxel gen import, and I'm also going to just import the voxel gen, import voxel gen v1, and then down here in unregister, what I can do is voxel gen v1 dot gen dot remove. That way it removes any of the shaders and callbacks when the add-on is reloaded. Okay, remove. And I'll just start Blender fresh. So let's just see here. So all of our stuff is being called. You can see all the callbacks. And if I save, the file, it removed the callbacks. It's not printing anything anymore because it unregistered it. Because whenever you auto reload the scripts in VS Code with that extension, it will call unregister, and this will get called, and so it'll unregister everything before it re-registers it. So good idea to get everything removed. Okay, so we have our registers. So we have frame change pre and our graphical stuff. Let's see, now what do we do? Well, let's define some points and try to draw them. And then, so once we draw some points on the post view, we can, well, where is this? So frame change pre, this is essentially our update right here. So I'll just put pass. I don't want all this stuff printing constantly. So frame change pre, we can generate some points and then draw them in the draw post view. So we'll say, we'll just do points batch equals none. We'll just do that for this moment just to see how things react. So points batch equals, and we'll do utils.graphics create points batch, and it takes in that parameter chords, and we'll just define chords as an empty list for a second. And let's say we can actually get the frame that it's on, and let's do this. Let's say frame equals scene dot, let me put in the type, so scene, and I don't really want to use the depths because it's the one that it's being built, so it's kind of, I don't even know if you're supposed to really use it. So frame current, so we'll say frame, I think you can actually get scene dot frame end as well, so you can get like a scale. So if it's like, if it's 60 frames per second and it's 120 frames, then you can have, you have like 2 seconds worth. So we might just deal with that here in a minute. And I was saying you could like lerp, so many units per second, but you'd have to know your frame interval, to get your basically your delta time in between each frame change. So that way you can multiply your velocity by it. Let's just go to Blender and look at something real quick. So there's c.scene.frame current. All right, we already know that one, frame current, and we know frame in. Okay, and how do we get the frame rate? That is, what does that one say? See, I think that's under a whole nother area. Frame start, step. Let's look at step. No, frame current final inflow preview set start step subframe. That's not it either. We'll just edit this source. Render empty. What? Render empty. I know you can get this pretty easily somehow. Show frame rate. C dot. What else would it be under? Let's see. This is going to be the space properties context. Oh, that's not very helpful. And it's not telling us down here. Oh, I'm looking over here when I was doing that. Okay, I actually have an add-on where I made something with that, so I'll just show you. Open folder, lab repos, archive, and it's like KFX trails, I think. And it will be under panels and draw frames, scene, and frame jump, frame animation, frame start, frame end, FPS. Oh, scene.render, and it's on there. Wow. Sometimes I just forget stuff where things are located. So scene.render frame, wait, FPS. There it is. And there's also this FPS base. I'm not even going to worry about that. So we could say FPS equals scene.render.fps, frames per second. And then we can get end equals scene.frame end. And then we could say, well, that's our total frames. So this is our frames. We have this amount of information. I'll just show you. So we have our little timeline here. We know that the first frame is going to be 0. Let's say our next one is going to be 100, or our last one's 120. Its FPS is 60, let's say. And so you go 0 to 120. Say you're on, frame, I don't know, let's say 30. Say you're on frame 30. So that means, half of this right around here, okay, this would be 60, and this would be 60 on this side, right? And so if you're here, that's half of the 60. So if it's 50 or 60 frames per second, and you're at 30, then you know that you've been running for half a second. All right, half a second. And if you're traveling at a certain speed, you can divide all that up and get if it's miles per hour, kilometers per hour, something like that. You could break that down to, say it's, I'm not going to try to remember everything, but basically if it's like you're traveling 10 miles per hour, okay, So it'd be 10 mph. Okay, that's per hour. So then you would divide that by 60 to get minutes. So that would be, let me just get a calculator, and just so we can keep track here. So 60, or well, we'd say 10 miles an hour, divide that by 60. So you'd be traveling at 0.166, repeating per minute. So it'd be 0.166 repeating per minute. That's, oh boy. So we'll just say 0.1, whoa, I can't use MS Paint. So 0.166 repeating, and that's miles per minute, MPM. And then if you want to get down to seconds, you divide it again by 60. So this is how many miles per second that you're traveling, boom. And that's, divided by 60 again. But you can simplify this, just do 60 times 60. 60 times 60, and then you would just divide your miles per hour by this. And that's how many it would give you per second. So, if you're traveling this much per second, and, at frame 30 is half a second, well, then you would get this as like a percent, and then get your percent of this. So, you would do, whatever frame you're at. So 0 would be your base, and then 60 would be your max, but you're on frame 30. And then, wait, this would be X, this would be 100. So it's like is over O. So it would be 30 times 100 times 60. So 30 times 100 divided by 60. That gives you 50%, which we already knew that was going to happen, but I'm just showing you. So I multiply this, okay, and then divide by this. It's so shit. Okay, and that'll give you 50%, so you take 50% of that. So, I'm just showing you how to work it out. So 0.0027 divided by, times, we'll just say times 0.5. So you're traveling this fast. Okay, so you're traveling this fast per second. Well, that's miles per second in this example, miles per second. Okay, so that's why you need the frame end and all that good stuff. But you basically need to get your, you need to get a lot of stuff. All right, we'll just close this out here. That's just speed stuff anyway, and I'm not even doing speed yet. And this is just like to keep things kind of to make sense. So like if you're moving arbitrary speeds, you don't really know how to calculate anything. And I know this is like the cellular automata thing I was showing you, but the idea that I have is to actually treat a little bit of these rule sets as like particles that have motion to them. I don't know what I want to get into exactly. I just want to get something to be interesting, like get a good working playground to try ideas with. So I want to just basically implement all the different types of ideas possible, just so that they're sitting there ready to be used. So anyway, coordinates. We can just go ahead and create a grid in the first place. So let's just look at creating a grid. So you have an X, Y, Z. We'll just do an X, Y, but if you were to draw these 4 points out, we would need to go, this would be -1, 1. This would be +1, -1. This is both negative. So negative, negative, positive, negative, 1, 1. So it's positive, positive, and then negative, positive. All right, so that's these 4 points. So basically, if you do something like this is the point of me saying that. I'm just kind of looking at that, but if you do this right here, for I in range, and you do like 10, well, that's 0 through 10. You don't get a negative anywhere in there. I'll just say X. For Y in range 10, for z in range 10. And we'll say point. I'll just draw this out for you first. So vector, I say u first, but I need to see it too, most likely. So we'll say chords dot points, or chords dot append, and we'll say point. And then we're going to go ahead and batch that, and then in here we can draw it. So it would be as simple as this right here. Oh, and you put CLS dot points batch. We can go right here and say utils dot graphics dot draw points batch, and it takes in the batch. So CLS dot points batch takes in a color. We'll just do blue. And it takes in a size, and we'll just do 2. And we'll also check that this isn't none yet, so we don't make sure if. Then we'll just draw it. So let's go to Blender and see. All right. I'm gonna delete everything. Boom. And there is our grid being calculated every frame. All right, so that's what I was saying. We kind of want to center this up. So what we could do here is just move those vectors, or add an offset. Now it starts and stops it. It does look pretty good. So let me play around for a little bit, and then I'll come back and show you what I came up with. All right, so I'll show you where I got to so far. So if I just push voxel gen grid, you get this green grid right here, and then if I press spacebar, these little dots start moving. All right. So the key to this so far is that I created a voxel class. Okay, and this is going to be an instance class here, but the positive x is its neighbor, and it does wrap. So you can just use modulo. So I think I did 10 right here for the grid size. So it's 10 by 10 by 10. I think that's what I got set. Yeah. So it's 1,000 points. It's just 10 cubed. But say this is 10. So I would do like plus 1 on the positive x to get the neighbor. Well, since it's wrapping, it will go back and get this one. So you can actually do that in Python easily with the modulo operator, and that's what this right here is doing. So x plus 1 modulo the grid right there. It's basically like this. Say I have the grid is equal to, say, 5, and I say for I in range 10, and then I just do I modulo grid. You can see it goes, well, I did something wrong. Oh, I put an ampersand. I meant to put the percent sign for modulo. There you go. See, it goes 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So it kind of wraps that index around. So x plus 1 modulo the size of the grid. Because this function gets the actual index of that voxel. So from index. And you can see if you pass the index, it just makes reference to the grid. So the x is going to be the index. So it's grid times grid. And then this one is the floor division to make sure it returns the integer. But yeah, anyway, this just basically sets up the voxel and its neighbor coordinate, or its neighbors by index. So I guess something that we could try doing real quick is, okay, so I did something, I don't really know. I gotta go in and think about what I'm actually gonna be doing here. So it's just a start, and it's just something to look at, the groundwork, but basically all I did was just create more noise. Yeah, that's not really any kind of structures or anything going on. So what I would like to do now is let's start this one more time. See, it just goes straight to starting too many at once. I think what I need to do is like start with just one simple thing, and then like if all neighbors are not active. So if, let's say, if all neighbors are equal to 0, then let's say you would switch it with something like, then positive z is true and positive y is true, something like that, you know. So you would say something like voxels, then you would say voxel dot um, positive z equals true, well, dot active, and let's say let's do positive y, and then we'll say if the total number of active is greater than 3, deactivate it. I guess that's something. Yeah, so it just goes straight to noise. So I got to figure out like what I'm going to do. All right, so I guess on the next episode we'll, continue this, but I'll have planned out a little more with it. But I wonder something real quick though. If I say grid is equal to 50, I wonder like a stress test what it could do. That's a lot. Yeah, I don't think the computer likes that. I don't even think I like that. I can't see anything. But okay, so we know kind of the limit there. Let's just do 20. I mean, that's still a lot. Well, it kind of organized itself a little bit. I'll go back. Let's just do 15. Maybe that'll be a little easier. Well, I'm not sure. But yeah, I'll have to think about what we got going on here. And you know, I think some of the rules I would like to do is like, let's just go back to the start here. So like, if this one is selected, then maybe it should, if this one's selected and no other neighbors are selected, then select all the neighbors. But then that would really quickly deactivate neighbors. Let's set this to activate neighbors. I'll just have to think about what we got going on here. Equals true. This will just activate everything so fast. So if the neighbors is not selected, then we'll do voxel dot activate neighbor, pass in the voxels, and then this, I'll just show you what I mean. Like everything would get activated right away. Boom. For the most part. Probably has some kind of grid formation. And then we could say, like you could check if certain things are true. So like if positive x, and if positive x and positive y are true, dot active. Actually, let's do it like this, and then we'll just be silly and just deselect everything just to see what we get. Voxel dot deactivate neighbors. Yeah, it didn't even do anything. That's too much. So I'd have to just do something like, so if the positive x and positive x and negative x is active, then we'll do let's just do a simple flip. We'll just do a simple checks. Like if the left and right are positive, then we'll turn those off and do something else. So we'll say voxels if positive x dot active, and let's check this one's active. So voxel dot active, if voxel dot active and positive x is active and positive or negative x is active, then we'll deactivate these and then activate, so positive x, negative x, and then we'll activate the y and the y. Let's do an else. Else equals true. Yeah, so see how it got stuck like on one level? That's kind of what I was running into earlier. So you gotta like maybe do something for the z, but then you go really quickly to like this big noise. So I gotta figure out how to kind of clamp that, you know? But basically, let's see if the z, do we do z? So if positive x and negative x is active, turn those off. And then we'll do, let's do elif positive y is active. Then we'll just, I don't know. Positive x equals false. You just could come up with so many combinations. I don't know. It's like I want to turn more off and see kind of like some kind of structure in there. X, Y. It's too much on the Y, or too much on the Z is getting activated. Positive Z. Let's just turn this off. Equals false. Well, that's a little better, I guess. I don't know. Wonder what it will do at 60 frames a second. Kind of unseeable. Let's do 24. I almost wonder if it's creating a structure yet. So it looks like the negative x could be negative x. Now this isn't like how you should really do this, but and negative x is active. Let's turn off negative x in this one. We're just flipping switches like who cares? I'm gonna slow this thing back down. Well, a little faster. I mean, it's kind of interesting, I think. I don't know. Let's try ramping it back up. I want it to do something. Well, it's kind of doing something. Not exactly what I had in mind just yet, but anyway, I guess, you know, I'll just go a little slower and I'll just, test the boundaries a little bit. It's gonna be a lot, but here we go. This whole side is getting filled up though. I think that's because the modula is gonna like make it jump over there, so everything's wrapping over to the left. So it's actually the plus X. But I don't know. It's some kind of structure. Anyway, like I say, it's V1. I'm just now getting into this idea. So we'll, think of something interesting to add to this, and yeah, we'll see you later.